Hi there YouTube, Stu H back again. So a quick video on the craft beer pie 3.0. I've been scratching my head with a guy called Troy this week on how you can control the two elements inside. Now, when we first looked at it, we kind of thought we'd probably just wire the two elements together. So if you don't know, inside the Brewdevil, effectively there is two elements. There's a 700 watt element and there's a 1300 watt element, which come together, obviously, to provide the 3000 watts. So if you select in the power menu anything between 700 and below, it will be either full on the 700 or pulsing the 700 to achieve that, or anything above that, so 701 to 3000 watts, 1300 watts, it'll either have the 1300 watt element on permanently or will be pulsing that to achieve that. And then anything above 1301 watts up to 3000 watts, it'll have both elements on and or pulsing those to achieve that temperature. So it isn't a true, it doesn't have a true, as far as I can tell, it doesn't have a sort of, should we say, a variable resistor in there, which is able to actually produce, say, 400 watts. What it does is it pulses a 700 watt element in a set pattern to achieve that. So when you're looking at potentially upgrading the controller, which is what we're looking on the Brew Pi project, and there are some videos that need to go in front of this one, but I will get back to doing those. But this is just because we're collaborating and I wanted to record it now so that we can sort of be looking at the same thing. So the head scratch became, how do you control two elements from the software, because the software isn't really set up to necessarily control a single pot with two elements. It seems to be better suited to, well, two independent elements, shall we say. It seems better suited to be able to, you could wire two elements together in the same pot and use the control on that, and that would be fine. So what the best way I found to approach it is actually to, I hope you can see on the screen here, I've set up a boil, what is effectively a boil pot per element, or per combination of elements. So we've got 700, we've got 1300, and we've got 3000. So if we flick the power on the 700, as you can see on the LED, it flashed and went off. Why did it flash and go off? Because the target temp isn't set to anything. So it's not going to carry on rising, because as far as it's concerned, it's achieved the target temp. I can do the same with this one, the 1300. You just see a minor flash there. Yeah, there you go. And then with the, obviously with the 3000 watts, you get both, okay, and it turns itself off. So how have I achieved that? So the first thing I did was go to add-ons, and add-ons is basically, people have written additional bits of code and added to Brew Pi through GitHub, through the distribution there. And what I added was groups. I've probably shot straight past it, haven't I? Groups. Why can't I find groups? Absolutely mad. There it is, groups. So written by Joe Alloway. Big thanks to him for doing that. You can go to the GitHub repository where the code is. Actually, you can just download it from in here. And it allows you to group the actors together and group actors and sensors together, which is actually quite helpful. So how does that manifest itself in the system? So if we go to hardware, so traditionally you can just add an actor, and an actor is obviously anything that you want to control with a relay like so. You can control that input with anything between 3 and 32 volts. Which the Raspberry Pi puts out about 3.3 volts on the GPIOs, so you can trigger those. I've got it set up to come out of GPIO 17 on a frequency of 50. So traditionally you could only do one actor, and then you can only do one actor per boil pot, but with what the groups allows you to do is to give the group a name, select group, and then you can select multiple actors per group. Now I did try originally to use the same actors that were powering the 700 watt pot and 1300 watt pot to do the 3000 watt pot, but it ran into an issue basically where it would set the target temperature on the 3000 watt pot. It would flick on all three, but because it wasn't writing the target temperature over to these two as well, these would just override and turn off because their target temperature hadn't been set. It was only set here. It sets the power across these, but it doesn't set the target temperature across. And it's just the way it's been coded. But I've managed to, by creating a second set of actors with exactly the same. So if you look at my 1300 here, one element that I'm using for the 1300 pot, it's absolutely identical to the 1300 WM, which is the second one. So it's exactly the same, it's just got a different name and it's just assigned to a different pot, but effectively it outputs on the same pins. So that's how I achieved it effectively. Got a one wire temperature sensor in there, and then of course I've just aligned the 1300 to the 1300, the 700 to the 700, and under there I've got the group selected, which is the 3000W, which is this group here, which contains 700 WM and 1300 WM. And what that kind of allows you to be able to do is, now if we go to the brewing system, I've put in some basic brewing steps, and sorry, this is going to be 3 minutes. I had tried to select it for a shorter period of time. I'll probably jump through once I've shown you a little bit of up and down on the first so you can see the LEDs working, I'll probably skip to the final stage and show it again there. I've just got the probe in a glass of cold water, and then I've got a glass of hot water separately. So I stick it in the hot water, you should just be able to see the temperature come up. Should come up, there you go, it's coming up quite quickly. There we go, 25. So we'll take it back down. So obviously you've got to set all the boil pots to automatic, and if we press go, it will start the first stage. So it's gone straight into countdown, as you can see here, because it's actually heating, and I believe it probably was above the target temperature. So at the moment it's heating because it's in the cold water. If I put it into the warm water, you can obviously see the green LED is on, so that means there's power going to the element. Now put it in the hot water, and as it rises and ticks over 28 degrees, and as you can see, it's set the 28 degrees here, it's set as the target temp. Once it goes over, it turns off, you see the green LED go out, so there's no power on the element any longer, and we can go down again, and you should see it switch back on again as it ticks down in the cold water. Now, what I would say is I'm probably going to hide these elements. I don't think it really matters to show those. It's really just for understanding what's going on when you're testing, if you sort of have them there. So obviously it's come back on as it's cooled down. So let's skip to the next stage, which you can do. Next step. So as you can see straight away, the 1300 watt element will have come on. And if it was just left around a sort of mashing temperature within sort of half a degree, there are some different PID technologies you can choose from, and there is an auto-tuning function which I'm really looking forward to trying out, which allows you to run a test run with your boiler, and it will keep pumping the temperature up and down, and it will come up with customized values for your system, and then you can input them back into the PID logic, and that should allow you to provide much better granular sort of step mashing. So we're going to skip on to the final stage. Take my word for it, as the temperature drops again, 1300 element will click on. There we go, it's on again. So as we jump to the final stage, next step, we go to 2 elements, and there you go. You can see now that it's using the full 3000 watts, and obviously this would only be in the boil stage, or you can program this how you want on the left, right? So when people are programming the Brewdevil, what they quite often do is use sort of 1600 watts for 1 minute to get things up to temperature, or a couple of degrees below. So say your target temp is 45 degrees, you set it to 43 at pretty much full power, it'll click off there, overrun by a degree, and then you set your actual mash time for say 60 minutes at a lower power. So it just allows it to ramp up to happen much more quickly. But you can absolutely build as many steps into here as you want to achieve that. So you can see both elements are on and heating. I'll move it back to the the warm water, and you should see them tick off again. So effectively, this seems to be the kind of best way to achieve that. I think it's, has it not started counting down? Yeah, there we go. Because it hadn't reached target temperature, it hadn't actually started counting down here. So now that it's a target temperature, in the same way the Brewdevil works, it doesn't actually start counting down the specific boil or mash cycle that you're on until you've actually achieved the temperature. So there you go. So that's how I achieved that. If you've got any questions, give me a shout. In fact, you can give me a shout on anything to do with this. I am going to go back and start at the beginning of the project, and I am going to try and work out what the cheapest way to do this is, because currently I'm doing this on a Raspberry Pi version 4, which is not the cheapest way to approach this. So I'm going to go back and look at maybe doing it on a 2 and seeing how cheap we can pick a 2 up. The idea would be to potentially replace the screen that's in the Brewdevil with this, and then everything else would be driven from a web browser, from an iPad, iPhone, or a laptop computer. You can do all your programming there. You can save all your recipes as XMLs, etc. There you go. The brew process is finished and the lights have gone out. So yeah, it just, I guess it makes programming the unit a bit more simple. I'm lucky at the moment because I've got an HLT that has 2 elements in it. So probably I'm not going to gut my Brewdevil at the moment. I'm quite happy with my Brewdevil, but I'm super interested in this project just because it does offer potentially quite a significant upgrade in the future in terms of how you can manage and store your recipes, how you can quickly build and program a recipe. There's a whole bunch of other stuff in here. You can set this all up so it will click on in the morning, and you can even build in like flow regulators and actuators and things like that. So you could even have it, pump your HLT full of 30 litres of water exactly, stop, and then heat that to 45 degrees for you. You go mad. You can do as much as you want, or you can make it as complicated as you need to. I don't think I'd probably go to that extent myself, because I like to let my water rest for a few days. I'm going to pour it, put some Camden tablets in it, and then leave it to stand to let some of those nasties evaporate off over a couple of days before I actually use it for brew. So hopefully this was helpful. Hopefully that makes it clear how you can use Craft Beer Pi version 3 to control 2 independent elements of different ratings within a single system, and then how you can basically do a bit of basic programming. Hopefully this was helpful. Catch you all soon. Cheers.